Today, we are diving into a tiny data format that is causing a massive shift in the world of artificial intelligence. It's called FP4, and trust me, it's all about doing way more with a whole lot less.
And look, this isn't just some lab experiment tucked away in a corner. We're talking about the world's biggest companies re-architecting their data centers and betting big on a whole new generation of hardware from NVIDIA, and it's all built specifically for this new tech.
The promise here is huge, making AI faster, cheaper, and way more accessible. So, you gotta ask, right? What exactly is this 4-bit future? How in the world does it work? And maybe the most important question, does it actually hold up when the rubber meets the road? Well, let's dig in.
So, NVIDIA's CEO, Jensen Huang, he's basically saying this is a fundamental turning point. The old way of doing things, with general-purpose computers, it just won't cut it anymore. Companies need to shift to what he calls AI factories. These specialized powerhouses built for one thing and one thing only.
And this isn't just talk. The adoption is already happening. And look at this list. You've got Disney using it for entertainment, Lilly for discovering new medicines, TMC for making better chips. I mean, the heavy hitters from totally different industries are all jumping on board.
So, why all this effort? Well, the core problem is pretty simple, actually. Modern AI models, the ones powering all the cool tools we use, they're incredibly powerful, yeah, but they are also absolute beasts when it comes to memory and processing power. They're just so hungry. And as these models get smarter and smarter, this hunger for resources becomes a huge, massive bottleneck.
And that's exactly where FP4 comes in. It stands for a 4-bit floating point. Basically, it's a numerical format that dramatically shrinks the size of the data that AI calculations need to chew on. And the promise here? It's huge. We're talking massive gains in speed and efficiency, which could totally unlock the next wave of what AI can do.
Okay, so how is this even possible, right? How can you shrink data down that much without just breaking the AI? Let's get into the nitty-gritty and check out the technical breakthrough here.
Right, so this didn't just appear out of nowhere. For the longest time, 16-bit formats, they were the standard for training AI. Then, pretty recently, we got this 8-bit breakthrough, which is just now becoming the new normal. FP4 is the next, very aggressive step in that evolution. It promises to be nearly twice as efficient as even those new 8-bit formats. It's a huge leap.
Okay, but here's a really important detail. Not all 4-bit formats are created equal. You've got a couple of different approaches, like one called MXFP4 and then NVIDIA's own version, NVFP4. And the research is pretty clear. NVFP4's design, with its smaller block size and more precise scaling, it just works better. It delivers optimal results. Yeah, you can think of it like having a more finely tuned instrument. It just gives you the right balance between how big of a number you can represent and how precise it is. And getting that balance right is absolutely critical to making this whole thing work without losing accuracy.
Okay, and the other part of the secret sauce here? It's really clever. It's a 2-part strategy for how the AI handles rounding numbers. So check this out. When the AI is doing a calculation, the forward pass, it uses a really stable, predictable method. Think round to the nearest. Super simple. But on the way back, when the model is actually learning from its mistakes, that's the backward pass, it switches to something called stochastic rounding. It's basically probabilistic. It's kind of like flipping a coin to decide whether to round up or down. And that little bit of randomness is key. It stops the model from getting stuck in a rut, from developing these rigid biases, and it helps it learn correctly, even with numbers that aren't super precise.
But, okay, there is a limit. See, as the model trains, the little signals it uses to learn, they're called gradients, they get smaller and smaller. And eventually, they get so tiny that they just get lost in what's called quantization noise. It's like trying to hear a whisper in a crowded room. And when that happens, the model just flat out stops getting any better.
Okay, so that's the theory. That's the cool research paper stuff. Now let's jump into the messy reality of actually writing the code, where, as you're about to see, one tiny bug can bring the whole thing crashing down.
So get this. This is a quote from a real GitHub issue that developers filed that implemented this new FP4 tech, and suddenly the AI was just spitting out total gibberish, corrupted, garbled text. I mean, this cutting-edge model was completely broken.
And the cause? Oh man, it came down to a single deceptively simple line of code. The original code used a command called torch.empty. Now what that does is it creates a little container for data, but it doesn't clean it out first. It just fills it with whatever random junk data was left over in the computer's memory. The fix?
It was as simple as switching to torch.zeros, which does the same thing but makes sure every single value inside is set to a clean, predictable 0. I mean, what a tiny change for such a huge problem.
So here's what was happening. That random junk data from memory, the system was trying to read it and it was getting converted into errors, specifically what we call not a number values, or nans. And once you have one of those errors, it spreads like a virus through all the other calculations, poisoning everything and completely corrupting the final output. It's just a perfect and kind of scary example of how when you're working in this super low precision world, the tiniest little oversight can cause a total system failure.
All right, so let's zoom back out for a second. What is this whole thing, this intense push for 4-bit and all the crazy challenges that come with it? What does it all mean for the AI industry as a whole?
So while you've got engineers pulling their hair out over these really tricky technical bugs, there's a much bigger debate brewing in the developer community. And this comment from a Reddit user just nails it. Attempt at vendor lock-in. The big fear here is that by creating these super high-performance, but also proprietary formats like NVIDIA's FP4, you're essentially forcing people into your ecosystem. You know, vendor lock-in.
But, and this is a big but, here's the other side of that coin. The reason people are even considering it is because the incentive is huge. NVIDIA is claiming that using their format can give you a 3-fold improvement in price to performance. So you see the tension, right? It's this constant battle between wanting open standards that work for everyone and the incredible allure of these massive performance gains that you can only get from one place.
Okay, so this whole conversation can get a little confusing because of two words people often mix up: accuracy and precision. Let's clear that up real quick. Think of a dartboard. Accuracy is hitting the bullseye. That's the correct target. Precision is just hitting the same spot over and over and over again, even if that spot is way off in the corner.
And that's the key to understanding FP4. The whole goal here isn't to be less accurate. It's to achieve the exact same accurate result, to still hit that bullseye, but by using numbers that are way less precise. It's about getting the job done just as well, but with a tool that's much cheaper and more efficient to run.
All right, so let's wrap this up. What are the big takeaways here? First, the promise. FP4 offers these massive efficiency gains. Second, the problem. It's not easy. It needs these highly specialized formats and tricky rounding techniques to even work. Third, the practicality. We saw how in the real world, a simple coding mistake can have huge consequences. And finally, the debate. This whole thing just fuels that ongoing tension between getting the best performance and the risk of being locked into one company's tech.
Look, at the end of the day, FP4 really does promise to make AI more powerful and more accessible than it's ever been. But, as we've seen, it's not a free lunch. It brings a whole new layer of complexity and risk to the table. So the real question isn't just, can we make this tech work? We've seen that we can. The bigger question is the industry ready to navigate the really delicate trade-offs it brings? The trade-offs between raw speed, real-world stability, and the ideal of an open ecosystem that this whole 4-bit revolution is forcing us to confront.